In the last video about conic sections, we discussed the parabola extensively using the graphing form, how to find the vertex, the axis of symmetry, and in fact, in another video we talked about inverses of parabola. This time we want to talk about another conic section, the one that occurs whenever I take a plane and slice it directly across one of my double cones here, and that will provide a circle. So let's talk about circles. The standard form for the equation of a circle is the quantity x minus h squared plus y minus a k quantity squared, and that's equal to a radius squared. This is the standard form of the equation of a circle. So that's standard form. And let's dissect this just a little bit. H, again, will be our horizontal shifter. This is where the center point of our circle is going to be horizontally. So H is a horizontal shifter. Then K will be our vertical shifter, where on the y-axis, or where in relation to the y-axis, our center point is going to be. And it works pretty much like this. Whatever will make this a 0, whatever will make that phrase a 0, let's say I have x minus 3 quantity squared plus y minus 2 quantity squared, and that's equal to 9. The square of the radius will take this distance here and square it. So in this case, where I have the radius squared is 9, my radius then would be 3. And where is the center point of this circle? The center point of this circle here will be whatever makes this part of the equation 0. So x at the center point is going to be 3, and then y at our center point, at our new origin, would be y minus 2, so then y would be 2. So our center point would be at 3, 2. That would be the new origin of our circle. So let's take a look at what graphing circles looks like. Let's try a couple out. Let's try one where our center point is right at the origin, just to make things easy. Let's go back to that 9. So here we have the equation of a circle, and I know it's the equation of a circle because my x term is squared, my y term is squared. They are both positive. That's very important. Both terms are positive. And it's equal to the square of a radius. So in this case, if I'm looking for a horizontal shifter, remember my horizontal shifter on a circle would be the opposite of h and the opposite of k. In this case, x is not being added to anything before squaring, or subtracted anything from x before squaring. So my negative h is 0. Same thing with my y. My negative k, my horizontal shifter, is 0. So my center point is right at the origin. And in all other instances, we would look for where to position, where to reset our origin. Where is going to be our new 0, 0? And we'll see that in a second. In this case, our r is the square root of 9, or 3, so I can go 3 from that distance there, 3 up here, 3 back this way, and let's go 3 down. And basically I have a nice arc, nice continuous arc that will be my circle. A little lopsided, but you get the point. So here, my origin, my center point is at 0, 0. My origin of the thing, of the graph, my radius is 3, and so this is the circle that is the graph of this equation here. Let's take a look at another example. Let's try one where we do have a shifter, x, let's say minus 4 quantity squared plus y minus 2 quantity squared, and we'll set that equal to 16. So in this case, we do have a horizontal and a vertical shifter. We know that our center point is now the opposite of h and the opposite of k. So the opposite of this h would be a 4, and the opposite of this k would be a positive 2. And basically what we're doing is we're looking for the point that would be the new origin. So the equation tells us that the new origin is 4 and 2. So we'll have to draw a point at 1, 2, 3, 4, and 1, 2. This is our new origin. We've shifted it right and then up. And so our radius now is the square root of that number there, which is 4. So I can go 1, 2, 3, 4, and 1, 2, 3, 4 down from there. 1, 2, 3, 4. I have a point there, and up again. 1, 2, 3, 4. And these are all connected by a nice, perfectly drawn circle with a radius of 4 and a center point of 4, 2.